What is up, Internet? It is I again, that guy again, and today we're going to be doing, what is it, part 4 already? Damn. Of the Kingdom Hearts 2 hack through. We're still in Twilight Town. We could actually play the game. We could actually progress, but that's no fun. Today what we're actually going to go through and do is, it's going to build on what we learned last episode a little bit, where near the end there, we had found that if you go to Sora's entity, right, or any entity, let's say, right, and then we know from our previous research from 5 CO offset of that, right, boom, 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 there's a pointer, and that's the pointer that leads to Sora's like stat page, right? But if we take it a little bit further, right, if we go just a little bit further than this and we say that we go another 250 bytes, there's this 4 byte value here. And this is actually some kind of encoded pointer, right? That leads to the party stat page, right? Or like the entities like strength, defense, like the stuff you would see if you go into this menu, right? Like the status screen, or like the abilities and stuff like that, right? So that's kind of the missing link we were looking for. But the weird thing about it is it's not an 8-byte pointer, it's a 4-byte pointer. And so we actually kind of have to see this break on access. All right, there we go. Just kind of have to see how it's being used. And actually you can see here, we're just straight up taking 250 offset from the A register, and that's all she wrote. So from here, we see it jumps to this 4AEC60 code. We're going to open up our handy dandy G Hydra, and we're just going to type in 140 4AEC60. Take ourselves over here, and we can actually just see this function, right? It returns an 8-byte value, which is the pointer, and it takes a 4-byte value as an input, right? And so from there, it just says if it's 0, return 0. Otherwise, we go through this crazy ass function and figure it out from there. And we could write our own C code to do this or whatever, or our own assembly code to do this. But as far as for us to convert it, we're going to actually make our own auto assembly cheat to do the conversions for us today. But what we're going to do is we're going to go ahead, we're going to label this. We're going to call it convert. Actually, we'll just say short to long pointer. I'm fine with that, right? And then there's got to be one that does the opposite, right? Turns a regular pointer into a short pointer. Let's do this. To find that, I noticed that it uses this like data value, right? Like some kind of table there. And it looks like there's a total of 2 functions that reference that. ECBO is the other one here. Oh goodness, there's a lot of shit going on here. It's referenced by a few functions. Let's just do it this way. Start from the top. This takes, this one actually might be the other one. We might have actually found it. Hold up. Yeah, there's a lot of references to it, so this looks about right. Let's do this. Let's go and grab the address of this function, right? And then we're gonna run the game, and we're actually just gonna go to Kingdom Hearts 2 final mix.exe plus that, and we're gonna put a breakpoint here. And so we see RCX is the, what would you say, parameter. There's 0 there, so it's not going to do anything. Now it's a full, RCX is a full like memory address, right? So let's step out. And we see in the A register, it has left us the 4-byte pointer. So we've basically gone ahead and we found one function to convert like from long pointer, regular pointer, 8-byte to 4-byte pointer, right? And then we found one that does the opposite too. So now we can kind of hijack these, because as far as like us actually going through and traversing through Sora's entity or whoever's entity, we can't tell Cheat Engine by default to use this 4-byte value as a memory address, because we're on a 64-bit operating system, right? An 8-byte operating system. Let's see, what are we doing? Long to short pointer. There we go. All right, so now that we know 2 important functions for what we're trying to do, right? We're going to be able to kind of architect our cheat a little bit, right? So let's go back to Cheat Engine, run it, break the breakpoint. There we go. We're back in action. And so the idea here of what we're really going to do is we're going to basically make an assembly script, right, or an assembly cheat. And the goal of the assembly cheat is going to be to allow us to, on the fly, convert to and from these 4-byte pointers, right, in case we want to change a value, like that's stored by a 4-byte pointer, right, to refer to something different, or if we wanted to, figure out what we're looking at and kind of decode them. So we're going to need to create an assembly script that allocates some memory for us to input and output those variables that we want. And then additionally, we're going to want this cheat to basically run like every frame, or as close as we can get it to every frame, right? So we need somewhere to hook this at. And honestly, if we break this, right, this runs every frame just about, right? And this is one of the functions we're using, so we don't want to like, hijack it. But if we step out a couple times, let me make sure I don't have a breakpoint. All right, cool. Step out once or twice. I usually like to see, like, go until I see, like, get calling code from a register or so. And if we were to, like, break here, that's every frame. That's, like, every frame. And I guess there's a chance that it might not call here. But we have a pretty decent way of getting this to go through. I mean, if we wanted to be 1000% sure, right? Actually, I'm curious. What if I set this to 0? Because it's like, this only doesn't run if AX is 0. It's like it set itself back, okay. Well, yeah, this should be pretty safe. I don't like to do inserts in the middle of jump instructions because it can muddy them. But if, let's say, we did something like here, that doesn't run at all. Okay. Oops. Let's see. Because it's in the middle of some, like, loop. Honestly, it might not be a problem because Cheat Engine will automatically adjust the jumps, I believe, for us. Yeah, Cheat Engine should adjust the jumps for us. Maybe. Let's do this. Let's just go to where we were here. I kind of like this area better anyway. And I could actually just go at like the top of this function or something. Yeah, we just go like right here. Cool, I like that better anyway. Okay, cool. So yeah, we could just put it like somewhere here probably. Yeah. Alright, cool. So yeah, this is where we will insert our code at. Goodness gracious. Here, let's just Control+A to open auto assembler. We're going to do a template cheat table framework code so we can enable disable it in our cheat table, and then we'll do code injection, and we'll just tell it to inject stuff there. Alright, cool. So this is our handy dandy cheat. There's actually, let me go back real quick, there's another thing or two we could figure out before we get too deep into the weeds, but let's say this. We're going to make first probably the one that goes from short to long, right? Because that'll make our lives a little bit easier. And as far as the cheat itself, sorry, I'm trying to get back to my auto assembler. Here it is. So we're going to need to actually allocate some memory, right? We're going to need 12 bytes times 2, because for the short to long, we'll need 4 bytes for the short and 8 bytes for the long, so that's 12 bytes. And then for the long to short, it's just the same thing in reverse, right? 8 for long, 4 for the short. So 12 plus 12, we're going to need about 24 bytes of storage, right? So allocate, we'll just say pointer info will be the name of it, right? 24 bytes. You don't have to do this last parameter, it just tells it like where in memory to place the info if it can. Actually we'll just leave it out. I don't care too much about it. It's fine. So we'll allocate it, but we're also going to do something else where we're going to register symbol, right? Which is going to allow us to refer to pointer info in our cheat table, and you'll see in a little bit, it's pretty cool. But what we're also going to want to do, if we're allocating memory and if we're registering a symbol, then under the disable part, we want to deregister the symbol and we want to deallocate the memory, right? So I'm pretty sure it's deregister symbol. It might be unregister symbol. No, it's unregister symbol. It always throws me off. Okay. So then we'll say pointer info, just like that. Nice and easy. And then we'll just put a dealloc in there. And it'll reallocate the space and reset it up every time you turn the cheat on this way, so you don't have to worry much about it. Alright, so now that we've got the memory allocated, we're going to want to check and see something, right? So we're going to work on the code that does the short to long first. down. Sorry, sometimes G-Hydra takes a minute to search for stuff when you're first getting it open. Let's see. Alright, here it is. So this will also tell us the memory address of what we're looking for here. Right there. Copy that. And what we really want to see is we really want to go and we want to check what registers are being set or changed by this code, right? Because if it's going to change like the RCX register, for example, and there's code that depends on the RCX register that we're like inside of, right? When we're injecting our code, it'll just crash the game if you don't preserve it. So you need to know what registers to preserve, right? So we're gonna just probably run it a couple times till we get a good one. Yeah, this is good. Okay, so we'll step out actually. Right here. So we're going to put, what I like to do is I like to do a break right before the call instruction and right after, right? We're gonna run it. So we hit the first break. We're gonna ignore this one. These are the registers before we call the function, right? And we're gonna run it. And we see that RAX and RCX are the only two that have been changed, which I'm actually really happy about. All right, sick. So, all right, so we're gonna have to preserve RAX and RCX for short. Just curious, I wonder if it'd be the same for the other one. Let's see, I honestly think it was just 30 instead of 60. Am I wrong? It's 30 instead of, that's amazing. All right, cool. So we're gonna go back, toggle breakpoint, do this 30 instead of 60. There we go. Put a break here, run. All right, cool. And then we're gonna step out. All right, here's the code we want. Same way, one breakpoint before, one breakpoint after, run it, and then run it. And it actually looks like for the long to short, it also deals R9. Okay, so we're gonna say long Rex RCX R9. Cool. That's just for when we get to it. So, all right, sweet. So we got some cool details here. Let's get back to our auto assemble script. And so, actually, you know what? So, yeah, this is great. Okay, so this is gonna be for short. We're actually gonna just kind of preserve these addresses too real quick. And you don't have to, I just like to have my hex capitalized. It just makes me feel better, I guess. I don't know. Let's see, for AEC 30. All right, sick. So what we're gonna do essentially, oops, sorry, scam call. Goodbye. Okay, so what we're gonna do essentially is we're gonna, RCX, RAX is return value. Sorry, I'm just plotting and scheming. What I might do is I might go ahead at the very start. New mem is where our code is, right? We're gonna just out the gate push RCX, push RDX, push R9, and then at the end we'll just pop R9, pop RDX, pop RCX. There we go. So that way we just won't even really worry much about it. And then in the meantime, what we'll do is, so as far as the structure of our pointer info memory that we've allocated, right? The first 12 bytes are going to be for short pointer to long pointer, right? And of those first 12 bytes, the 0 offset from that is going to be the short pointer, and then +4 offset will be the long pointer, right? So what we'll do is first we want to go ahead and we want to ascertain the short pointer, right? And to do that, that's actually just going to be offset a 0 from pointer info. So since we have everything pushed already, wait a second, this should be RAX, not RDX. Oops, we almost messed up very vividly. Okay, cool. So we're going to go ahead, move RCX, the value stored at pointer info, right? And actually we need to be real careful because if we do it this way, move RCX, it's going to say, hey, RCX is an 8-byte register. We're going to move 8 bytes into RCX, and we don't need that. We want ECX, right? Additionally, I'm also going to put something here, XOR RCX, RCX, right? And what that's going to do is it's going to basically make sure that the entirety of the C register is set to 0 because it's an exclusive OR. Like, it's kind of weird. It's just a trick where you're setting the whole register to 0, yeah. But it's a bitwise trick. Makes you feel bitwise. But anyway, so we're going to have ECX, the 4-byte value, take the 4 bytes referred to at pointer info. And then from there, we're going to want to go ahead and do our first call, which is going to be this one. And you gotta, so like I'll show you guys, you would think that this would be fine, right? But it's not. You have to have the quotes before and after the process name.exe for it to work. And it'll tell you if it's not going to work, but 9 times out of 10, that's the problem there. But this is going to take the value in the C register, convert it, and then in the A register, we're going to have our return value, which in this case is the 8-byte pointer that we want to put into pointer info plus 4. So we're just going to simply say move pointer info plus 4, and then we'll say RAX, the whole A register, the whole 8 bytes, because we want an 8-byte value to go there. Bada bing, bada boom, right? So we've got all that set up. Now we're going to go ahead and do the one where we put the long in there. Sorry, I just had a brain thing. My cat's meowing in the other room. So we're going to do the one where we put the long pointer in and convert that to a short pointer. And the way we're going to do that is now we're going to move into the RCX register, the whole register, right? The value referred to by pointer info plus, this would be 12, right? Which is C in hex, I think. A is 10, B is 11, C is hex, or C is 12. All right, cool. So there's that, right? And then from there, that's going to put that 8-byte value into RCX. So we're going to just call, actually, I'm just going to plagiarize this line. We're just going to call the one that does the 30 instead. That's the long to short, so that's the opposite of what we're trying to do. And then from here, sorry, cat is distracting me. All right, so from here, now we have in the essentially EAX register 4 bytes that refer to the conversion that we just did. And we need that to be at is it a 16 offset? Hold up, I gotta do some mental maths here real quick, because it would be plus 4 to C. Yeah, C is gonna be an 8-byte value. That's right. So that would be 20. 20 is 14 hex. Okay. So we'll say move the pointer info plus 14. We're going to test this and see if it works, but we're going to move the EAX in there. And I think that should be right because that's the 4-byte that goes in there. And then that'll leave it up to 18, which is 24. Okay, perfect. So I think this is actually right. So now that we think we've got it right, we're going to say File, Assign to Current Cheat Table. Just close the thing. You don't need it anymore. And then it's going to be down here as an auto-assemble script, right? So we're going to rename it. We'll say like pointer convert, right? Just make it easy. And then we will add to new group just because it makes it easy, right? We're actually going to call the group, we're going to call that pointer convert. I like that a little better. And we do want address version. That's going to be, for the address, we're going to put pointer info, right? And then we're just going to say, okay, that's fine. And I'm actually going to rename this to enable because it's like this way you enable the cheat. We'll click on pointer convert, right click, group config, and hide children when deactivated just to make it a little bit less muddy in our table. And all right, cool. So now we've got our enable. We're going to have to add a new address. I just kind of add some blank address to be able to drag it in there, because then it's a little bit easier to edit it. Because what we're going to want here, let's say this, we're going to have the short to long first, right? So we'll say like short pointer, which is going to be a 4-byte value. We want it to display in hex, and this is going to be plus 0. All right, cool. So now copy paste, right? We're just going to change short to long, adjust address by 4. All right, yeah, that's cool. There we go. And then I'm actually going to make another group, right? Add a new group, short to long. Do we want address version? Yes, we do. And it's going to drag it all the way to the bottom of the table for some reason, but that's okay. We're not worried because now short to long has an address of plus 0 as a group, right? We're going to do the same thing where there we go, right click, group config, hide when deactivated. There we go. And then now what we can do is we can actually just copy and paste, and we'll say short to long, long to short. Bam. There we go. And we actually need to change long pointer to be an 8-byte value. Oopsies. All right, that's cool. And then if we go and we look at the code again, because I have to see how we structured it for, let's see, change script. So for the second one, it's move Okay, so it's the 8 byte first and then the 4 byte for the second one. So we'll have to flip it for long to short. So we'll actually just say the first one's going to be an 8 byte on this one. That's a +0. That's going to need to be +8 instead in that case. And that's going to be 4 bytes. And then we need to change this to long pointer, change this to short pointer. All right, amazing, amazing. And I actually want to make sure these are all displaying in hex as well, which they don't necessarily have to. It just makes life a little easier. All right, cool. So now that we've got this orchestrated, we're just going to go ahead and go back to our breakpoint. Gonna make sure we don't have any breakpoints. Awesome. Let's see if our cheat works. Let's just go ahead and enable it. And all around me are familiar faces. Our game just crashed. Well, let's go and load it back up and find out why. All right, we have returned. We have returned to the land of the hackers. And so what we're going to do is we're actually going to try to find out why it's crashing. It's not as hard as you would think. And actually the cool thing about it is I think this is roughly where we set our... I want to say this is where we set our break, but let's do it this way. Let's right click on enable. We're going to go change script, and we're just going to grab this address right here that we're allocating into. Control G, paste. All right, very good. Put a breakpoint there. There we go. And actually what I might do, I might just put a breakpoint a little bit before it just to be safe side here. There we go, run. All right, cool. So now we're going to actually enable our cheat. And in real time, you're going to see it's going to change this to a jump, right? So we're going to step into a few things, go to our jump. This is where the problem is. It's trying to call. So yeah, 9 times out of 10, it's that you fucked up the function call. So instead of having the brackets around it, that's telling it to check the memory, like it's telling it to use this code pointer as like a pointer to a code pointer, if that makes sense. Like instead of it calling code, it's like calling a code pointer, and that's the problem. So we just need to delete that, click OK. Sometimes it's cool enough to where it'll fix it for you. Sometimes, if you're lucky, you can de-enable it or disable it, then re-enable it. And it looks like this is working. Maybe we might have broke things. Let's just see. No, everything is good. Everything is actually doing a lot better than I thought it would. So, okay. So now that we've got this, right, let's go to source stat page. We're just going to copy paste so we can get a new entry. We're going to change this to be the, what is it? We'll call it party stat page pointer, or a short pointer. It's kind of wordy, but it'll do. And so I remember it was plus 250, and we need it to be hex. There we go. All right, so theoretically we should be able to take this, plug it in here, get this. Everything has gone black. What? What? So, huh. What? Why did everything go dark? I'm very curious here, actually. Let's see. So it does the stuff. It pops the stuff. It goes back. It calls the normal code. Okay. What are we missing here? So, like, for some reason, though, the screen goes black. We must have hooked some kind of, like, rendering function or something. Like, that's the only thing I'm thinking that makes any sense. I mean, I see R9's getting messed with. Okay. So like I'm seeing the registers that shouldn't be getting fucked with, right? Let's try this. Let's put this in here. Run 1 frame. Okay. 1 frame. Boom, boom, boom. Bam. For some reason, it's almost like it doesn't run code. Test RBX. Wait a second. So RBX is just zeroed out. Okay. We don't use RBX. We use RAX. Now RAX is a 1 instead of 0. Now it's a 0. Huh. It's almost like the game just forgets how to operate because we're in that little... So maybe it's just the area of memory we're messing with, right? Let's do this. Let's change script. See, I'm real worried about changing stuff now though, because we've already kind of typed a lot of shit out for this. I mean, really, I guess the important stuff would be this. We're just gonna gut it. We're just gonna gut our code. All right, so we're gonna take this. We're gonna take this. And we're gonna take this. There we go. Okay, so now that we've got all of that taken, we're actually just going to wipe this whole thing out because we're crazy. All right, we're gonna say cheat table framework code, code injection. Ah, this is where we need to figure out where we want to do our jump. So what I'll actually do is I'll go and we'll say browse this memory region, break on access. All right, there we go, delete breakpoint, step out, step out. We stepped out too many times last time, I think was our problem. This will suffice, I believe. This will be perfectly fine. And in fact, we could probably get away with doing some shit like, let's just do right here. Let's go right here. We're gonna insert ourselves here. 3B160, or wait, 3B1620, 3B1620, okay. 3B1, okay, sick. It remembered force, I like that. All right, so now that we've done that, we're gonna take the guts of our code that we just ripped out. We're gonna slap some things together. Gonna slap some things together. Who would have thought the easiest path to darkness was to hack Kingdom Hearts 2? Let's see. Throw that there. Amazing. Save it. See if we break things. Maybe, maybe not. Run. Alright, there's no breakpoints. Sick. So, enable. Okay. Okay, moment of truth, y'all. Moment of truth. Let's go to this. Take this. Will we see darkness? No darkness. Amazing. So now let's go the other way around, right? Ooh, something's wrong. Oh, I know. So we need to set this to +C. That's right, we forgot to do that. So now we've got that. We're gonna paste this here, and it does it backwards for us too. So amazing. We now have the ability to convert short to long pointers and vice versa in KH2. But yeah, guys, it's become a little long episode, so I'll probably edit this, get it up, and then see you guys again tomorrow, okay? Thanks, and have a good one.